Hey everyone, this is Bradley Bush with another algebra video for you. Today we're talking about arithmetic sequences, specifically how to find the nth partial sum of an arithmetic sequence, and we have some worked examples for you. If this is your first time watching my videos, welcome. I'm thrilled that you're here. I hope you enjoy it. If you do enjoy it, please consider subscribing to the channel, giving me a thumbs up, or making a comment. If you're returning, thanks for coming back. I really appreciate it. First question, what is an arithmetic sequence? Well, an arithmetic sequence is a sequence where each term after the first differs from the previous by the same amount. And we call that same amount the common difference. So the first term of each sequence in this example here, the first example, we have 6, 4, 2, 0, negative 2, negative 4, and then it keeps going. The first term is 6. The first term is just given to us, and we call the first term A1. But after that, each successive term differs by the same amount. You can notice that each of these terms, I'm not sure what that number is, each of these terms differ by 2 after. So 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0, and so on. So our common difference is negative 2, and our first term is 6. In the next example, we have 13, 17, 21, 25, and 29, and so on. 13 is the first term, that's a sub 1, and the rest of them, a sub 2 is 17, a sub 3 is 21. But the common difference, 13 and 7, you go up by 4. 14 and 21, you go up by 4. 21, 25, you go up by 4. So the common difference is 4. So the first term is 13, and the common difference is 4. The general term of an arithmetic sequence can be written like this. A sub n is the nth term in the sequence, equals a sub 1, which is the first term of the sequence, plus n minus 1 times d. D is the common difference, and n is the nth term, the number for the nth term. So say I wanted to find the 8th term, then I would do a sub 8 equals a sub 1, whatever the first term is, it would have to be given to us. And then I would have 8 minus 1, which would be 7, times the common difference. And I would have to either find the common difference or it would have to be given to me. But it's a great way to find any term that you want in an arithmetic sequence. Both of those two previous pieces of information will help us here. This is the focus of the video today, the nth partial sum. So if you have an arithmetic sequence, you could take the first n terms, so say n is 10, you could take the first 10 terms of the sequence and you could add them all up. So say, let's pick n to be something a little bit bigger. Let's say n, for just hypothetical purposes, let's say n equals 200. So this would be s of 200, so the 200th partial sum, and you would go A1, A2, all the way up to A of 200, and you just add them all up. So you can do that, right? But that's a lot of work, adding 200 separate terms together. So lucky for us, we have a more concise definition below. And that definition is S sub n, which is the same nth partial sum, is n divided by 2 multiplied by the quantity a1 plus a sub n. So the first term in your partial sum and the last term in your partial sum, you add them together and you multiply that by n divided by 2, and that's your sum. Let's do an example. Find the sum of the first 100 terms of this sequence, and the sequence that we're given is 1, 3, 5, 7, and so on. So it looks like it's all of the positive odd integers, which is an infinite number, right? And we are looking to add up the first 100 of them. And I don't want to list them all out and then put them into a calculator, so I'm just going to use this formula. The formula, again, is S sub n. So we're 100. We want 100. N is 100 in our case. So the 100th partial sum is going to be 100 divided by 2 multiplied by, and we need a sub 1. We can see from our little list here, a sub 1 is 1. plus, we need a sub 100. We don't have that, but we can use the general form of an arithmetic sequence to find it. So a sub n, we're looking for a sub 100 equals a sub 1, which is 1, plus n minus 1, so n is 100, minus 1 times d. What is d? What is the common difference? If we look at this, we go 1 and 3 is 2, 3 and 5 is 2, 5 and 7 is 2, so the common difference is 2. So we will do 100 minus 1 times 2. Now if we do a little bit of algebra, we get 1 plus, we get 99 times 2. That gives us 198. And we have 1 plus 198 gives us 199. So a sub 100 is 199. We can plug that in now. We have s of 100 equals 100 over 2. I'm just going to say that's 50 as I'm simplifying. And I have 1 plus 199. That gives us 50 times 1 plus 199 is 200. And 50 times 200 is 10,000. So if I summed the first 100 odd integers, I would get 10,000. I think that's kind of cool. Let's try another one. This will be our last example. So it says find the following sum. So you may have learned about this summation notation in a previous class or in a previous video if you're watching my videos. So you know that you could just do as I've done below. This is really asking find the sum of 5i minus 9, where I goes from 1 to 25. So you could just say, well, I equals 1, I equals 2, I equals 3, all the way up to I equals 25. You could copy and paste the 5i minus 9 25 times, and then change the I to 1, 2, 3, and all the way up to 25, and then do the algebra, and then add them all up. You could do that. It might take you a little bit of time, but it's totally possible. Or we could try to use a faster way. We could use the nth partial sum formula that we just learned. We have everything we need, actually. We have the first term, and we have the last term. And we have n, because n is 25. So let's try this. So we have s of 25 because we're adding the first 25 terms together. This equals n is 25 over 2. A sub 1 we've calculated already to be -4. And we add to that a sub n. We've calculated a sub n to be 5 times 25 minus 9, which is 116. That gives us 25 divided by 2 multiplied by 112. We can do some simplifying here. The 2 can go into the 12 56 times. And that leaves us with 25 times 56, which is 1400. So if I had done this longhand, added up all of those terms, all of the terms that that you see now in blue, where I equals 1, I equals 2, I equals 3, all the way up to I equals 25, then we would have gotten 1400. And this way, we just had 2 lines of some quick arithmetic, and we're done. We just needed to calculate the first term and the last term, and then do some algebra. So hopefully this was helpful. Hope you enjoyed it, and have a great day.